And so we know this is what we're supposed to get. And so now let's go ahead and differentiate this using first principles. So we know how the thing go already. We'll always start with the formula. So start with the formula by saying f prime of x. We know that f prime of x is supposed to equal to the limit as h will go to 0 of f of x plus h, f of x plus h minus f of x plus h minus f of x over h. Yeah, man, f of x plus h minus f of x over h. Then what do you do now? F of x was 1 over 2 root x. So this will become the limit as h tends to 0 of, this is going to become 1 over 2 times the square root of x plus h minus 1 over 2 times the root of x. And then this is being, of course, divided by h. So then what do we do now? We, of course, rationalize. So we rationalize this, so this becomes the limit. This becomes the limit as h tends to 0 of. When we rationalize, well, don't rationalize yet. My apologies. Sorry. We're going to write this as one fraction first. Write the numerator as one fraction first. Then we multiply up this to become, write the numerator as one fraction, root x minus root x plus h over root x plus h. And then this is now being divided by 2 times root x plus h times root x. So I write it as one fraction first. So my bad to say rationalize first. You write it as one fraction first. And remember, this is all being divided by h. Now, look at this now. When you have a fraction a over b divided by c, or a divided by b over c, then you can rewrite this now as the limit. This is now the limit as h approaches 0 as, I'm just going to write this as one fraction instead of a fraction over fraction. So writing it as just one fraction instead of fraction over fraction, it is root x minus root x plus h over, now this becomes 2 times h times the square root of, now look at this now, this square root x can come inside here by, we know that root times root, we can multiply them inside now, thirds, so this will just become x times x is x squared plus x times h is xh. Yeah, man, so govern. Then what are you going to do? You're going to rationalize the numerator. So you're going to rationalize the numerator. No, we know rationalize the numerator by multiplying by its conjugate. The conjugate of the numerator is going to be root x plus h, root x plus h, root x plus h. Yeah, man, this is the conjugate. Root x plus h divided by, this is now 2 times h times the square root of x squared. Wait, the conjugate, sorry, what am I doing? This is root x plus h. So now we can multiply across the conjugate. We're almost there. Now, when you multiply across the numerators, just notice what you're going to keenly observe. You're going to observe that in the numerator becomes a difference of 2 squared again. So in the numerator is just going to become the limit as h approaches 0 of The numerator becomes the difference of 2 squared, so it becomes x minus x plus h. Yeah, man, that's how the numerator becomes x minus x plus h divided by, now I'm not going to tell you any lie. To expand out this in the denominator would be crazy. And so I'm just going to write it as 2h times the square root of x squared plus xh, x squared plus xh multiplied by root x plus h. Because if I were to expand that denominator, that would take forever. So that is crazy. You always want to do less work. We don't want to do that much work. So this is what we have now. So since this is what we have now, what do you notice? Well, what I notice is the x minus the x will cancel each other. So if we want to do it in one step, right? Because when you multiply across the numerator, it becomes the difference of 2 squared. This will actually make this become x minus x minus h, and then x minus x cancel each other. So x minus x cancel each other. And so all we're left back with now is this right here, minus h over this. So now this h cancels this h. So now we can apply the limit when h is 0, because we'll finally cancel out the h. So we'll get minus 1 over 2 times, plug in h as 0 now, 0. Then this, if you plug in 0 right here, you get x squared, and the square root of x squared is just x times, plug in h as 0 now, you get times the square root of x, you get the square root of x, plus plug h as 0, you get another square root of x, but the square root of x plus the square root of x is 2 root x. So what we end up getting is minus 1 over 2 times x multiplied by root x plus root x is 2 root x. And then now look at this. So what we finally get is, the final answer is minus 1 over 2 times 2 is 4. So we get minus 1 over 4x times the square root of x. Was that what we got when we said this is what we're supposed to get? Let us check and see. Just to check and see if this is what we got. Minus 1 over 4x times root x. No, that's not what we got. But no worries. Remember, this x cubed can be broken up as minus 1 over 4 times, instead of saying x cubed, we can write it as the square root of x squared times x. And then by thirds, we know that this will work out to be minus 1 over 4 times the square root of x squared. It's going to be the square root of x squared times the square root of x. And the square root of x squared, we know that is x. So yeah, we get the same thing. We get the same thing, man. Minus 1 over 4x times root x. So yes, ta-dam, we get the same thing. Minus 1 over 4x times root x. So we get the same thing, man. We're good, we're nice. We're good. Excellent. Soft. Moving right along. So nice, we get the same thing. All right, so we got the same answer, soft.